Swayam Prabha. Digital India. Educated India.
Hello everyone, welcome back to my lecture. So we have already discussed quantity and price regulations of the government as far as externalities are concerned. So today we are going to talk about cost and benefits with uncertainty. In certain cases, we in a sense, like firms or government, they don't know what would be the maximum cost, and therefore marginal cost is unknown, and in that point of view, it's basically entire policy solutions or any sort of solutions becomes very uncertain. And then in particular that case, how should economy run? And this is what the discussion that we are going to discuss today, and we'll learn that how mandated mandated policy for pollution reduction happens, and also how the optimum level of equilibrium that happens, and how efficiently one can control negative externalities from the economy. So the focus will be to understand costs and benefits with uncertainty, like expected or probability of the cost incurred for certain expenditures. And here expenditure that we are trying to address is expenditure to control negative or positive externality. We'll try to understand efficient outcome in the market for pollution reductions. So we already discussed market for product, like goods or services. Like for instance, in our examples that we had tried to understand how the production or the outcome should happen in case of steel or garment industries, and at what level price should be set. And then if there is a negative externality arises in the production or consumption, for instance, then how that should be mitigated and what are the remedies. So in that particular discussion, we already discussed the role of the taxation or role of the subsidy, right? And then we moved from market for the product to market for the say outcome or byproduct of the overall production. Like for instance, pollution. If we consider pollution is arising out of steel productions as a negative externality, then definitely we also need to understand how we should eradicate or how to kind of arrest pollution. And then market for pollution also should be very important to understand. So in the pollution context, we also bring the concept called pollution reduction. Like in one sense, like when the cost increases, when we try to increase pollution reduction, and therefore marginal cost increases, and therefore one really needs to understand what is the market for pollution reduction. And when we talk about this, then uncertainty also comes quite big way, because from the firms or for the government, like as a policy makers, as I said, that is very important to understand what is the cost. If it is unknown, then obviously entire policy frame or design or firm's reaction all will be based on the probability or with the uncertainty. So we will bring the same concepts and also same discussion that we had in context of efficient pollution control debate that we discussed, where we discussed about the cost of pollutions or cost of any sort of negative externalities, and then we tried to bring pollution and pollution reduction trade-off. Like if we are focusing more on the policy or policy towards pollution reduction, then definitely cost will go up. In that context, overall pollution level will be reduced. Or if we don't spend much on the pollution reduction through the policy, then definitely pollution will be increased and then pollution reduction will be reduced. So we will bring the same concept like marginal damage in our initial basic model where we discussed this marginal damage. We kept it marginal damage as a demand function or demand curve, which is constant, and we also kept it as like horizontal straight line. So but then in this particular case, we'll be talking about market for pollution, and then we have taken two examples of two extreme examples. One is the case of global warming, and then we'll also discuss today that why global warming is one of the threats. And all of us, we know that global warming is one of the current severe environmental issues that globally that we are trying to arrest. Not only and this problem is not country specific. This is a global issue, just like ozone depletion issues that we try to tackle. And there are different acts and the rules both at the global level and also at the national and also the state and also at the local level. So in the first case that we'll be talking about today is like a market for pollution reduction in case of global warming. And in case of global warming, we are trying to bring this again we are trying to bring this concept of marginal damage, and in this particular case marginal damage is declining. So what does that mean? This means the benefit of the first unit of pollution reduction is quite high, but once the production process is relatively pollution free, then additional production are less important. And this is what exactly the feature of law of diminishing marginal returns for the reduction. And therefore this will look like this particular marginal damage curve will be declining, and it will look like just a demand function, and because the feature is diminishing marginal return. So if I kind of draw the diagram and then explain, that also will be much easier for all of us to understand what we are talking about. Drawing from the basic model that we had, so say here O is one origin and say O dash is another origin. So as we know that at O, like the corner on the bottom left, where we say that pollution is at the full level, like highest pollution there, and O dash at the right hand side, the corner is like say pollution reduction is at the full, where at O dash there is no pollution, and at P dash there is no pollution reduction. So at O, pollution level is the highest. That means there is no sort of cost involved for the pollution reductions. And O dash, there is the pollution reductions is 100%. There is no pollution at all because we are spending a lot of money for the pollution reduction. So that is what what we are trying to say. So so when we are saying that marginal damage is declining, the benefit of the marginal the first unit of the pollution reduction is quite high, but once production starts, then it will relatively pollution free. So it's basically diminishing. So marginal demand curve will be diminishing. So now one more point that we already know, we are just reiterating here, that social marginal benefit SMB curve, which is equals to marginal damage from the global warming, is very flat, because very little, the reason why it is very flat, it is like almost perfect elastic demand curve is very flat, because a little benefit to the society from modest additional reduction in the pollution. Like for the global warming, we really don't know the origin. First of all, we also don't know from which country it is actually starting or how to arrest. and from the society's point of view, is very little benefit that we actually get it from the sort of pollution reduction. And therefore, when we draw this, it will be very relatively flat or flatter marginal damage curve, which is nothing, is basically social marginal benefit. So when we are talking about 1 unit, so here you can see, if we recollect about our relatively perfectly elastic goods, or elastic goods is basically changes in the cost. If there is a more changes in the quantity happens, then we call it is those commodities are elastic commodities, elastic goods, right? So in this particular case, if we want to reduce 1 unit of pollution reductions, then cost is very less. So it's basically that's why it is flat. So on the vertical axis, we can say that is a price is basically cost of say pollution. So now marginal cost of pollution reduction on the part of farms or individuals are unknown. So this is what we kind of point that we are trying to discuss is like pollution, market for pollution reduction, but then with uncertain cost, where neither government or farm knows. Like say this is the first, like say, marginal cost curve, which is basically farm's marginal cost curve, which is unknown for especially for arresting or for addressing global warming. And we see here is a like equilibrium at this point. We are seeing like R1 amount of pollution reductions, and OP1 amount of pollution that are kind of getting it, right? So there are 2 ways that we discussed to efficiently control pollution. One is through price, and another through quantity control. In the price control, we already spoke about the taxation. In the quantity control, we already discussed with the fixed amount of or mandated amount of pollution levels or pollution reduction levels. And here let us begin first with the mandated quantity control. And here we can say like R1 and P1 is a mandated one. Mandated amount by the government. So government actually decides that OR1 amount of pollution reduction and OP1 amount of pollution can be allowed and can be kind of tackled at the policy level. So this is a mandated one. So now, from the marginal cost point of view, either firm or the government, we don't know how much marginal cost is there. If pollution is very severe, then we might need to spend more money to in order to control pollution. Or if it is clean, then it is fine. For example, the current debate that we are having it, and this is quite true in case of during stubble burning time in India, and especially post Diwali. That is one of the severe environmental hazard that we face, especially in the northern part of India, and especially in Delhi. So if you follow news, and there is a news on cloud seeding to create the artificial sort of rain to control pollution level at certain level. So that is very costly affair. And then for that, we really don't know how many rounds of the cloud seeding is required to control control pollution. So imagine that that kind of extreme cases where marginal cost is really high, like say MC1 to MC2. So now let's stick to the mandated level of pollution reductions or pollution level. So like say at this point, like at R1, so the total cost at R1 is going quite high, which is like say C1 level, and say this is point A. So with the high level of marginal cost, then and at OR amount of pollution reduction, mandated level, so cost that is incurred to achieve at that level of OR1 amount of pollution reduction, the cost is OC1 amount. And then at point we can also see, like there is the equilibrium point where SMB, like social marginal benefit, is intersecting with marginal cost curve 1. So here we can imagine here that point, like say OC2 amount of cost that is kind of incurred at the initial level of marginal cost curve, which is MC1, because MC1 and MD or SMB, they are actually intersecting at point, say at point C. At this point, the total cost that is getting incurred is like at C2 level. But then when marginal cost is increased due to due to maintaining that or for maintaining that mandated level of OR1 amount of pollution reduction, then certainly OC1 amount is much more higher than OC2 amount. So now see MC2, which is the new marginal cost, when cost is cost incurred is much more higher than the initial level, and MC2, like MC2 curve, is intersecting at point B with social marginal benefit. So mandated level of pollution reduction is reduced to R2, and pollution level is increased by P2. So now, as we know, as we move from left to right, it is basically pollution reduction is happening. If we move from left to right to left, then higher level of pollutions. Then obviously when we move from R1 to R2, means higher level of pollutions, and pollution reduction is getting reduced. So at this level. So at point B, which we are already sort of getting new equilibrium, where MC2 is intersecting with social marginal benefit, but in a way we are actually losing out the area, what we call deadweight loss 1, right? So ABC area is the deadweight loss area, but then at C level, which is optimum level at the initial level, but then as cost increased from C to A, then we are getting new optimum level, which is point B. If we move towards point B, then we are losing social welfare, what we call area ABC, which is deadweight loss. In this particular case, certainly B, although it is optimum, but then from the society's point of view, it is not very optimum, because deadweight loss is incurred, and also mandated level of pollution reduction is getting reduced, and pollution level is increasing. So now we have another one point here, point of discussion, that we really need to be careful. Like now we get another one equilibrium where MC2 is actually intersecting here. So now this is from the when we look at ABC area, and then from R1 to R2 area and P1 to P2 area, reduction in the pollution. that we are actually talking about when we are only focusing on the quantity check. So there are two ways that we already know. One is price check, like regulation on the price, and the other one is regulation over the quantity. So here we are looking at first we began from the quantity regulations point of view. Now suppose government wants to introduce tax, like for instance one major issue here, when we are here at either point A or point B, the cost is really high as compared to OC2 amount of level, where mandated quantity regulation, mandated quantity regulation for the pollution reductions and then overall pollution level, it is high. For the pollution reduction level, it is high, which is good for the sort of for the society, for the environment, but then certainly cost is very high with the higher cost level, right? But then if we look at the initial cost level, then OC2 amount of cost, which is much lower than OC1 amount of cost. So now suppose government wants to introduce taxes on the cost, like on the price, say the tax will be the equal amount of OC2 amount. So like OT amount of taxation is included. Once we include this tax, then we see another one kind of point where we see equilibrium point, and here say this is like say point E, and across point E we get another one point what we call D, point D, and D on the marginal damage or social marginal benefit point on the curve, and then the overall pollution reduction is getting reduced from OR further getting reduced from OR2 to R3, and pollution is getting increased from O2 to OP2 to OP3 amount of pollution. So we are getting much more pollution even with the taxation, because there is a less sort of incentives for the farms. And then here also we get what we see, deadweight loss, and this is our deadweight loss 2 curve, 2 area deadweight loss, and the area that we are getting it from the curve, like marginal damage and social marginal benefit areas, and also we are getting from this equilibrium point that we get it from marginal cost 2 curve. So in this particular case, if we control or if we regulate the pollution reduction level, like say mandate is OR1, then we also have we get equilibrium point at C, but then with the higher cost we are getting market is getting failed, and then deadweight loss is occurring. And then when we introduce the tax, like through price control, it's like OC2 amount of cost or OT amount of tax that is involved, and that's how we saw here, like some sort of again deadweight loss from the society's point of view. In the both cases, in case of global warming, we see that like deadweight loss will be there, and then but then marginal damaged or social marginal benefit will be very flat, and that's how it depends how much we are losing out from the overall efficiently controlled pollution level. So this uncertainty definitely arises because government and farms have imperfect understanding of those costs of pollution reduction in the farm. So when we are saying like we are moving from C to A or A to B or B to E, or say B or E to D, so this all happening because we don't know about say MC1 and MC2. So it is basically marginal cost is unknown to the government, and marginal cost is unknown to the farm, and that's how deadweight loss is incurring, right? So this is what the market that we see, market for pollution reduction with uncertain cost in the case of global warming. So now the other extreme case, let's also talk about it because these two are similar. So like market for pollution reduction with again uncertain cost, and in this case particularly we are talking about case of nuclear leakage. So that also has a huge sort of environmental cost, and here in the case of nuclear leakage, just an example, a very small difference in the amount of nuclear leakage can make a huge cost or huge difference in terms of lives saved. So that is the major issue here. Global warming benefit that we don't know from where and for how long it has been happening. There are policies, short term, long term and medium term. So from the benefits point of view and from cost point of view, it is very especially from benefits point of view, society gets very little from this global warming, the cost that is incurred. So definitely there is a health sort of impact on that, but then it is nothing as compared to say nuclear leakage if it happens, and there is a huge sort of differences in terms of life saved. So therefore huge cost is incurred and cost is involved. So if it is possible, of course, that marginal damage curve, which is equal to social marginal benefit of pollution reduction curve for nuclear leakage, is almost vertical, which means with each reduction in leakage, each unit of reduction in the leakage being very important in terms of saving lives, and therefore marginal social marginal benefit curves becomes very, very steep. So again, if we take the same basic model, if we can extend that model and then we draw, so here point O, where again pollution is at maximum level, and here pollution reduction which is at the maximum level, and on the vertical axis is the price. So price or cost of pollution, and here is like, so here marginal damage curve which is equals to social marginal benefit, and we say that marginal damage curve or social marginal benefit is very steep because changes per unit, the cost will be very high, but then life will be saved. So here quantity, even if I regulate quantity here, then its impact on the cost will be really, really high. So that is that is what we are trying to discuss here. So now again, government or the farm, they don't know about the exact cost, and therefore marginal cost or the cost is unknown. So here is first is marginal cost curve, and here we are again beginning with the quantity regulation first. So we are starting with the quantity regulation. So here mandated quantity regulation is R1 and P1. Again, this is mandated by the government. Now see marginal cost curve increased, and then we get new equilibrium, like say here at mandated level at OR1 amount of pollution reduction, the cost that is getting involved is like C1 amount at point A, because at OR the cost is like OC1, and then we also get another one equilibrium here. So at that at point B, where social marginal benefit is intersecting at B with marginal cost curve MC2, and here is say revenue pollution reduction is reduced from OR1 and pollution level is increasing. So this is the loss with the same logic like deadweight loss here. So now say second point is like through taxation, like price regulation. Price regulation, and here at the initial level like C2 amount, OC2 amount is there, is the cost or the price of the pollution, and this OC2 amount is much lower than OC1 amount. So with the mandated pollution reduction, cost is much more higher like OC1. We also have seen the similar kind of trend, a similar kind of fact in case of global warming, and here also in case of nuclear leakages, here also the cost will be really high. Cost is involved, and which will be higher than the equilibrium at point C, where the total price or the cost is OC2 amount. But in this case, we get new equilibrium point, which is E, and then deadweight loss, say like this is D. Deadweight loss, for that this is a huge amount from the society's point of view, and cost is getting really high. But then if I include tax, so at the tax OT amount or OC2 amount, if tax is included or imposed, then pollution reduction gets further reduced and pollution gets further increased, right? So deadweight loss is area of deadweight loss, like area BDE is much more higher than what we have seen in the global warming case. So this is primarily the difference between these two extreme cases. So in extreme negative externality cases, it depends how marginal damage curve looks like, or social marginal benefit. So it depends on the types of the pollution, and accordingly the curve, like marginal damage or social marginal benefit curve will be either steeper or flatter, and accordingly overall deadweight loss will be there. So just to sum up, price and quantity regulations point of view. So quantity regulations ensure environmental protections, like with the mandated pollution reduction level. In these two extreme cases, it is like R1 and P1 level of pollutions, but then at a variable cost to farm. So obviously farms will have much higher cost. Farm has to bear the cost. Price regulation ensure the cost to the farm, but at variable level of environmental protections. So if the value of getting the environmental protection close to right is high, then quantity regulation will be preferred. And on the other hand, if getting the protection close to right is not so important, price regulation are preferred. So it is basically from the policy's point of view, from public policy's point of view, it is basically government and the farm, they have to decide, especially government mainly decide at what level of pollution reduction happens, and at what level and what should be preferred. So if it is quantity regulations, then they will make the policy that way. If it is through taxation, means through price control, then also it will be introduced in that manner. So I stop here, and for this particular lecture, I have again used these two books, one by Jonathan Gruber, the other one by Joseph Stiglitz. So selected chapters will help you to understand these two important extreme negative externalities out of the production, and especially in context of pollution, and then how to efficiently control pollution, and how at the market level, how efficiently that can be controlled, that can be studied. So thank you very much for your attention, and I'll see you in my next class.